Good morning, friends. It gives me immense pleasure to be here again for my course, Engineering Thermodynamics. I am now in the definitions and the terminology of Module 3, which is Psychrometry. In this, we will be discussing about definition and the terminology of the Module 3 related to the psychrometric, that is about air conditioning, humidity, different types of temperature and so on. Psychrometry, then dry bulb temperature, wet bulb temperature and so on. So define the pure substance. Pure substance is a substance that has a fixed chemical composition throughout is called the pure substance, such as water, air and the nitrogen. A pure substance does not have to be of a single element. A pure substance may exist in different phases. There are three principal phases, that is solid, liquid and gas. A phase is defined as having a distinct molecular arrangement that is homogeneous throughout, its separated from other, if any, by easily identifiable boundary surfaces. Defined phases of the substance. We have the three types of phases, that is the solid, liquid and the gas. Solid, the molecules are arranged in a three-dimensional pattern, that is called the lattice throughout the solid. The molecules cannot move relative to each other. However, they continually oscillate about their equilibrium position. So they will not leave the space. In solid, all molecules will vibrate only, but their position will never be changed. They will oscillate, but it will be same and they will transfer the energy. In the liquid, the molecular spacing in liquid phase is not much different from that of the solid. So in this liquid, if you see, they are very far away, like this. Okay. So spacing is liquid phase much different from that of the solid phase, generally slightly higher, except the molecules are no longer at fixed position relative to each other. So they will move as per their gravity and their direction, their position will move. If it is the gas molecules are far apart from each other and a molecular order does not exist. They are very random. Gas molecules move randomly and continually collide with each other and walls of the container they are in. So define TS diagram. TS diagram is the diagram most frequently used to analyze energy transfer of the system cycle. This is because the work done by or on the system and the heat added to or removed from the system can be visualized on TS diagram. By definition of the entropy, the heat transfer to or from a system equals the area under TS curve. So this TS diagram will give that how much heat is transferred, and this by the first law of the thermodynamics, if you know that the heat transfer, you can find out the work done. So TS diagram, water is shown in this diagram. So okay, this is the TS diagram, and here all at different P1, P2, P3, and the area of this will give you the heat absorbed, and from there you can find out. And here we have S is equal to entropy is equal to X Sg plus 1 minus X Sf. Xg is a specific entropy of a saturated vapor, and Sf is the specific entropy of saturated water. Now we will see the HS diagram. Okay, this is also called the Molière chart. Molière or HS diagram, that is enthalpy versus entropy, was a logical extension of the TS diagram, that is temperature versus entropy diagram, first proposed by Gibbs, retaining the advantage of TS diagram but introducing several new advantages. A typical HS Molière diagram for a thermodynamic fluid such as steam is shown below. So it is very good diagram in which lot of properties you can directly calculate. Like entropy, you can directly find out all the pressure temperatures, line of the constant pressure, line of the constant volume. This is the saturated vapor line. This is the saturated liquid line. So here is the critical point. So all these type of things you can find out by help of the Molière chart. Define PVT surfaces. So the P means pressure, V means volume, and T means temperature. So PVT surface shown is for a material that contracts on freezing. So if you reduce the temperature, the size will reduce. The surface is described by the equation of state of the material and is the locus of the equilibrium state of the material. So this you can see here that solid, vapor, pressure, solid, liquid, gases. So in this, all these phases, solid, liquid, gases, their pressure, specific volume and temperature, this all you can find out in one diagram. The diagram shows regions associated with solid, liquid and the gas phases. Regions in which two phases coexist are normal to the TT, where liquid and solids or the liquids and gases are there, they are called the isotherm, and isobars are identical. As a phase change takes place, materials goes from one phase to the other and the volume of the change takes place. So in a two-phase system, when liquid to the gas, pressure and the temperature will remain the constant. Only volume will change. So this you can observe in this PVT surfaces. So what is the dryness fraction? Dryness fraction is defined as the ratio of the mass of dry stream, that is the vapor, to combined mass of dry stream, that is vapor, and mass of liquid in mixture. So dryness fraction is the ratio of the mass of the dry vapor divided by the combined mass of dry steam, that is vapor, plus mass of the liquid. It is denoted by X. The value of dryness fraction lies between 0 and 1. So we can define in the mathematical way as dryness fraction X is equal to mass of vapor mv divided by mass of vapor mv plus mass of liquid ml. For the saturated liquid, dryness fraction X is equal to 0, and for the saturated vapor X is equal to 1. This you can see here. This is X is equal to 0 and X is equal to 1. So this we can depict here, that is the saturated liquid and the saturated vapor. And here it may be between 0 to 1, 0.5, 0.6, 0.9, 0.1, 0.2 and so on. Define the dry bulb, wet bulb and the dew point temperature. So the dry bulb, wet bulb and the dew point temperatures are important to determine the state of the humid air. Dry bulb temperature, it is denoted by TDB. Dry bulb temperature usually refers to as air temperature in the air property, that is most common used. It is called the dry bulb because the air temperature is indicated by the thermometer, not affected by the moisture of the air. So this dry bulb temperature is usually for air temperature, is the air property that is most commonly used. It is called dry bulb because the air temperature is indicated by thermometer, not affected by the moisture. Can be measured using a thermometer freely exposed to the air but shielded from radiation and the moisture. Means if the moisture and the radiations are not there, a normal temperature, what thermal reading you are getting, that is called the dry bulb temperature. The dry bulb temperature is an indicator of heat content and is shown along the bottom axis of the psychrometric chart. So in the psychrometric chart, the bottom axis is shown the dry bulb temperature. Now what is the wet bulb temperature? It is called TWB. The wet bulb temperature is the temperature of adiabatic saturation. This is the temperature indicated by a moisture thermometer bulb exposed to the airflow. Wet bulb temperature can be measured by using a thermometer with the bulb wrapped in wet muslin. The adiabatic evaporation of water from the thermometer and the cooling effect is indicated by a wet bulb temperature lower than the dry bulb temperature in the air. The rate of evaporation from the wet bandages on the bulb and the temperature difference between the dry bulb and the wet bulb depends on the humidity of the air. The evaporation is reduced when the air contains more water vapor. The wet bulb temperature is always lower than the dry bulb, but will be identical with 100% relative humidity. So, when the relative humidity is 100%, then the wet bulb and the dry bulb temperature will be same. Now, define the dew point temperature. The dew point is the temperature at which water vapor start to condense out of the air. So, in the air, it is a mixture of vapor and the air, and if this condition is reaching to the dew point, the vapor from the dry air will start. You can see during winter some drops of water is on the grass and some plants outside. Those are the due to this dew point. When the atmospheric temperature is reaching to the dew point, the water will be separated from the air and this dew will be formed. The temperature at which air becomes completely saturated, above this temperature the moisture will stay in the air. So if you are going less than this, your saturation, your water will be out. If the dew point temperature is close to the air temperature, the relative humidity is high. If the dew point is well below the air temperature, the relative humidity is low. So if the dew point is well below the temperature, the humidity is low. So define the water vapor. Water is a unique substance. It can exist as a liquid, solid and gas, that is a water vapor, solid as a ice. A primary way water vapor increases in the atmosphere is through evaporation. Liquid water evaporates from ocean, lakes, river, plants and ground and fallen as a rain. A lot or a little water vapor can be present in the air. Winds in the atmosphere then transport the water vapor from one place to another. A major source of water vapor is a gulf. Most of the water vapor in the atmosphere is contained within the first 10,000 feet or so above the earth's surface. Water vapor also is called the moisture. Now, define absolute humidity and the specific humidity. So, as of now, we have discussed about different temperatures and all. Now, we will discuss about the humidity and specific humidity, because the air contains some moisture and the percentage of the moisture in air is called as a humidity. Absolute humidity expressed as gram of water vapor per cubic meter of volume of air. So, in air, how much gram in a 1 cubic meter, 1 meter by 1 meter and 1 meter, how many grams of air, this grams of water vapors water is present is called the absolute humidity. Is a measure of the actual amount of water vapor moisture in the air regardless of the air temperature. The higher the amount of the water vapor, the higher the absolute humidity. For example, a maximum of about 30 grams of water vapor can exist in a cubic meter volume of air with a temperature in the middle 80s. Specific humidity refers to the weight amount of water vapor contained in a unit weight amount of air expressed as gram of water per kilogram of air. So, the absolute humidity is grams of water vapor in a cubic meter, but this is the grams of water vapor in kilogram of air. So, that is so absolute and specific humidity are quite similar in concept. Now, we will discuss about relative humidity. Relative humidity, that is RH, expressed as a percent, also measures water vapor but relative to the temperature of the air. In other words, it is a measure of actual amount of water vapor in the air compared to the total amount of water vapor that can exist in the air in its current temperature. So, this relative humidity is expressed as a percentage, also measure water vapor but relative to the temperature of the air. So, as per the temperature of the air, how much percentage of water is present. In other words, it is a measure of the actual amount of water vapor in the air comparing to the total amount of vapor that can exist in the air at its current temperature. So, the relative humidity is the present with the maximum. So, that is called the relative humidity. Warm air can possess more water vapor, that is the moisture, than the cold air. So, in hot you can have more water vapor. So, with the same amount of absolute specific humidity, air will have a higher relative humidity. So, with the same amount of absolute or specific humidity, air will have a higher relative humidity. If the air is cooler and a lower relative humidity if the air is warmer. What we feel outside is the actual amount of moisture, absolute humidity in the air. Define water vapor. It is, so water is a unique substance. It can exist as a liquid, solid and the gas. So water is a unique substance. It can exist as a liquid, solid and the gas. A primary way water vapor increase in the atmosphere is through evaporation. Liquid water evaporates from oceans, lakes, rivers, grounds and so on. A lot of water vapor can be present in the air. Winds of the atmosphere then transport the, I think this I have done. Okay, so my next topic will be definition and the terminology, module 4th, that is called the power cycle. These are the references, that is P.K. Nog, Engineering Thermodynamics, Tata McGraw-Hill's 4th edition, Eunice Senegal, Michael A. Bowles, Thermodynamics and Engineering Approach. Any questions you are welcome to ask. Also, you should like and subscribe this channel. Thank you very much for the joining. Till then, be tuned for my next lecture.
Like, share and subscribe. Hit the bell icon for more updates.